Hello everybody, my name is John. I'm from Munro and Associates. Munro and Associates is an engineering consulting firm based out of Auburn Hills, Michigan. We take a design-first approach. We do that through benchmarking, tear-down analysis, design optimization, and cost reduction. We also provide manufacturing optimization. Today, we are at the 2025 Battery Show, and we are going to show you some of the places or the booths that we find interesting that we think you might find interesting. So stay tuned. Hello everybody, my name is John. I am with Munro Live. Today we're at the Marian booth at the Detroit Battery Show. I'm with Jim Taylor from Marian. Can you please tell everybody what your role is and all about your company?
Sure, John. Hey everybody, I'm Jim Taylor. Been here for 26 years. Not here, we've been here for 7 years at every battery show, but I've been with Marian for 26 years. And I'm in global business development, and these days I'm specializing in the world of energy storage, and specifically EV and ESS for this show. So worked in a lot of different areas with Marian, but today this is our fastest growing, I would say, part of our business.
The battery segment?
The battery segment is we do consumer electronics, we do medical, and we do general industrial, but this is our fastest growing.
Okay, so I mentioned this a little bit ago to you before we started rolling tape. I've been in battery for 33 years, no longer really in battery per se, hands-on, but all 33 years I have seen your die-cut components being fed into the line. I find it fascinating, all over the world.
Yeah, we are a global company and we have been around for over 50 years. And it's great to hear you say that. We have locations in Asia, in Europe, throughout the U.S., and really we are growing. We all do very similar things. We're taking thin, flexible materials and we're turning them into components that add value and that are designed by our customers. So we don't design, we build to suit the customer. So.
Exactly. Do you usually do this with steel wheel dies or rotary dies? How do you process the material?
Yeah, as far as processing, we use both of those and many other types of manufacturing. It kind of depends on the materials needed, the volume, the tolerances, and also the packaging that's needed. We spend a lot of time on how the customer, or with the customer, how they're going to get those parts into their assembly. And we have a large field sales team that's well trained, and they will ask those questions at the earliest design stages. Even at the conceptual design stages, we're trying to figure out how the customer is going to use the components they're trying to design.
Yeah, it really is a hand-in-glove type operation between your company and the guys designing the equipment so that they can get your stuff married into their stuff on the manufacturing floor. Exactly. Some of that stuff, I imagine, is pretty tricky to process, squishy and stretchy.
Take a look at it?
Yeah,
sure. For this show, we put together with one of our vendors sort of a hybrid. It's got both cylindrical cells in there, it's got prismatic cells. Really what it's designed to highlight is some of our applications. And again, we're not making the raw materials here, we're taking the raw materials, and we do work with the global leading manufacturers. I'm not going to name them, but they are throughout the world the global leaders. And what they do is they make the raw material, and we help our customers understand the best materials for their given application. So in the instance of these cylindrical cells here, this kind of represents an insulating layer that helps with potting. A lot of times these cylindrical arrays need to be potted. And a lot of times on top of there'll be a collector plate. And this is a very rudimentary example of a collector plate. And because it's metal, it sometimes needs to be insulated. So we've got a couple of different examples of insulating films here.
Makes sense.
Both a paper and both a high dielectric film. So batteries also get very hot. So we've got an example of a thermal gap pad, gap filler. Been around for decades, used extensively in the battery space.
I think the acronym is TIM, Thermal Interface Material, right?
Exactly, a TIM. And we do use the pads, and we also distribute the dispensable versions, because sometimes in a given topography, there's just not enough space to get a pad thick enough. So the dispensable is a very well-known option for us.
Very important.
Yeah. Also important is to take care of the battery itself and the cells. And we work with a lot of different materials to help with the shrinking and swelling that even prismatic cells will do. So a lot of times customers will ask us for a anti-propagation layer in between there. But oftentimes you don't need anything at all other than a cushion. And we work with a lot of polyurethanes and silicones that go in between the cells to act as a cushion and take up that that shrinking and swelling that takes place.
And also, I think variation on the plant floor. This is like a tolerance stack up to
Tolerance stack up
take
is
up
another-
that variation.
Exactly right, because what they'll do is they'll bond these together very tightly. There does
Yeah.
need to be some of that.
And
as
there's a
well.
squish factor too that they have to adhere to.
They call it compression force deflection. Yes, CFD is a common term, and we work very closely with the raw material manufacturers of that to help dial that in. It's a very precise calculation that needs to be done. Some customers worried about thermal propagation, and that's probably within the battery space our fastest growing topic. It's on the minds of every engineer who is using a certain type of battery chemistry. There's some that are less likely to be experiencing thermal runaway, but when they do, we have all kinds of inorganic papers and other elastomers that can help act as a flame barrier, but also provide that cushion as well. So it's actually creating two functions with one component. So it's a nice way to get more bang for your buck that way. So
Try to help eliminate or minimize thermal runaways.
Exactly.
Pretty much key.
Yeah, what we do is there's two types. There's passive and that's where we focus is on the passive. So
Passive.
it sits there benignly until an event hopefully doesn't occur. But if it does, it's there to
First
to
line
help
of
with that.
defense?
First line of defense.
Okay.
Yeah. If we want to come over here a little bit, we'll kind of peek over this table. Lots of different options. This kind of really shows on a greater level the level of detail that we're doing. So I mentioned dielectric barriers. Here's an extreme example of what we can do with a simple thick piece of film. We can put scores in there, we can put bends.
Complex.
You can actually fold that into a three-dimensional part that acts as a shield in a dielectric barrier. So one example of some of the converting we do.
Not only with this stuff, but with this complicated thing, again, hand in glove with the design engineer on the equipment
Yeah.
side. He's got to be able to get that
Yes.
from the reel, pick and place onto his own product.
Yeah, exactly right. And you mentioned reel. We most of the parts we make have an adhesive on there, and sometimes it's just for fixturing until the entire assembly is put together. But yeah, these types of converted parts are generally rotary die cut. You mentioned that earlier, and these can be put in place robotically. So we work very closely with some robotic companies out there that will pick and place these
Very fast too.
very fast, very accurate, and then we have to be accurate as well, because there's some very tight tolerances of the part that needs to be located on the on this reel. So if it picks it up off balance, it's going to put it in place off balance.
I think many years ago, before the robots got so sophisticated, I think I saw webs from you with registration points.
That's true.
And now they rely
Yep.
on vision from the robots.
They
right?
do rely on vision. They can make some accommodations to that. What you were talking about are these pin feed holes.
Yes,
Yeah,
there you
yeah.
go.
That's actually still used. We do a lot of progressive die cutting, so where you're stamping each feature in a progressive
Yeah, so you
die.
need it with your process.
Yes, exactly
okay,
right.
Makes sense.
So I would say we've covered a lot of ground. You know, the thermal management, I think, is something that not just much thermal propagation, but thermal management is another area. Keeping the batteries cool is important. And then we've got lots of different ways of converting die-cut parts that are thermally conductive. And then also,
If we go back to this
Yeah, sure.
part, is this actually cut this way, or is it cut separately and then joined together or married together?
yeah, it's actually cut that way. And you can
Okay.
see that we've not wasted any material in between. So that's an example of us working closely with our process engineers not to waste very expensive material. So that's it's a bonus for the customer, and it's also a way to make us more competitive.
This is a laminate?
That's actually a lamination, and I kind of flip this around. This is put in place by hand.
Oh.
So these are tabs that get pulled apart and then put in place by hand. So it's more of a manual operation. So.
Well,
And then-
sometimes you have to have the manual ops, right?
Exactly. If the volume isn't there, if the intricacy is just not there.
So this is squishy stuff we were talking about earlier.
Yep, that's a
Um,
urethane foam used extensively inside the battery pack. This one helps cushion the bottom cooling plate,
Okay.
and keep it pressed up against the thermal pads, and then that gets pressed up against the cells. So what it's doing is it's making a better thermal path for the conductive material, which is oftentimes a gap pad.
Is this harder to process on your side than some of the other materials that we see here?
You know, I would say not really. No, it's actually something that we can as easily as water jet cut. So very old school.
Oh,
it's
okay.
thick.
Yeah.
It's not extremely high volume, so it can be water jet cut. But no, we're doing this all around the world. You know, we just opened a plant in India, so that's our newest greenfield manufacturing site.
Okay, nice.
Very, very busy there already, and keeping our facilities in Suzhou and Shenzhen and some of the others equally busy. The nice thing about us is that we communicate very well with all those locations. We're all one big happy family, and oftentimes when I'm working with an engineer here in the United States, if manufacturing's over in Asia, it's important to have that closed loop of communications. And we hire people who speak and communicate well globally, so it makes for a very seamless supply chain for our customers.
Plus, you have a well-recognized name too. I mean, that helps. That goes a long way.
It does help, and I appreciate you saying that. It's a 50-year-old family company, and
50 years.
Yeah, 50 years, family owned, not for sale. We're just growing, one step at a time. So
Nice. Well, with you doing what you do, you're going to grow even more so.
thank
I
you,
believe.
John.
Is
Appreciate
there
you coming
any-
in.
Yeah, absolutely, Jim.
Take care.
Okay, thank you very much.